Hi, welcome to a new session of Circuits and Networks. In today's class 3, under MATLAB models of single-phase AC circuit, let us find what exactly the output voltage or current would be obtained across passive elements when input voltage of 230 volts with 50 Hz is applied as input. Already these kind of problems we have solved in our previous single phase AC circuits. Now today we are going to see the actual waveforms that are developed across these passive elements in the name of voltage and current. Okay, so we know from our past classes that whenever the input voltage is applied across RL circuit, the voltage leads current, whereas in RC network, the voltage lags current. Now, when a 230 volts 50 hertz voltage is applied to a RLC network as shown here, we have to calculate the current through the circuit, that is shown through 100 microfarads. In fact, it's a series circuit, so the same current would be flowing in 2 ohms as well as 0.2 henries also. So we need to obtain the voltage drop across each element, and we need to plot the graph of voltage and current waveforms using MATLAB. Okay, first you take the data which is given as it is. RMS value of voltage is 230 volts. Just to remember, friends, whenever these kind of questions are framed, 230 volts, whatever the value is given as a AC input voltage, its value is actually in terms of RMS value. We can convert that value into the maximum value or instant value based upon our requirement. Okay, so we have to consider 230 volts as RMS value, and the resistor, inductor, capacitor values are given like this. So when you connect a MATLAB circuit with input voltage source and RC parameters, this is how the circuit would look like. And the waveform of voltage, that is the input voltage, is sinusoidal and output current is also sinusoidal. But the difference is that current is lagging the voltage. Why is that? We can easily understand with the help of the analysis, that is the passive circuit analysis. We'll see what we are going to do with that. Let us calculate the maximum value of voltage. The maximum value of voltage is given by the RMS value multiplied with the root 2. So its value is 325.26 volts. Okay. So once this voltage is done, let me calculate the value of inductive reactance, that is omega L, or you can write as 2 pi FL, whose value would be 62.83 ohms, and XC value will be uh, 31.83 ohms. This calculations you can do with your calculators. You're going to get this inductive reactance as well as the capacitive reactance in ohms like this. Now clearly inductive reactance is greater than capacitive reactance. That is why the current is lagging the voltage. Now if I tell you calculate the total impedance with the help of these elements which are given to us, so impedance value in rectangular form is obtained to be 2 plus 31J ohms, and in polar form it would be 31.06 at an angle of 86.3 degrees. So the impedance value we have estimated in the form of rectangular as well as polar values. Now with this, after calculating the input voltage of maximum value as 325.26 volts, we can get the value of maximum current, that is the voltage, maximum voltage divided by the impedance value. The impedance value of the total RLC circuit is 31.06. So with this, the value of current would be 10.47 amperes. So the input voltage and the current through the elements, that is in the maximum form, are obtained to be 325.26 volts and 10.47 amperes respectively. Now with the value of the current, that is the maximum current flowing in the resistor, inductor and capacitor, I can calculate the voltage across the resistor, which is obtained to be 20.94 volts. The inductive voltage is 657.8 volts. The capacitive voltage is 333.26 volts. So you need to remember these values. One is 20.94 volts for resistor voltage, inductor voltage and capacitor voltage. And we have to check whether we are going to get the same values when you plot the graph under MATLAB. For this, let me open the MATLAB model. So you can see we have opened a new MATLAB model with untitled version, and we need to name it. Before that, we need to select the parameters which are given to us. For that, first let me select from the Simscape system under electrical. specialized devices, I'm going with the fundamental blocks of electrical. I need a single phase AC voltage source, so I'll apply to this block 1. Then I'll go with the elements, and I require branch of series RLC, so I have taken the branches also. Then I should get the value of measurements parameters, so current as well as voltage I'm taking into the consideration. Then do I require any electronic devices? As of now I don't require any electronic devices. And when I go with the specialized version, so I require this power GUI also. So that is also done here. Let me check what are the values I have selected. See, I have taken a power GUI. I have taken a voltage measurement, current measurement, passive elements, source voltage. So this source voltage, let me take it in a big size value, and the resistor value I'll account it for 2 ohms, because in the problem it is given as 2 ohms. So let us fix to 2 ohms, and that can be connected to this like this. Again, can have the same branch with inductor whose value, what is it, is 0.2 henries. So that is also done. So the voltage is given in connection with the passive elements like this. You have also capacitance. So for this I'll take C parameter. The value is 100 microfarads. So we'll take the value as 10 into the power minus 6. So that is also done. And we have a current measurement. So the current measurement, we need to put it in a proper way. So the current measure is through elements. So I'll take this current measurement like this, and I'll connect it to the source by this line. Then inductor and capacitors are closed. We should know what is the value of voltage across the source we are giving. Numerically we know the value, but we need to plot on the graph also, right? So that's why I have selected this. So all these are things. Now to get the outputs we need sinks. So you have to go for commonly used blocks. There you can see you have a scope. So I'll add scope to the system. Let me take this gain also here. I'll tell you what is the impact of gain is. Anything else we require? As of now, nothing. And go for signal routing elements also. From and go to. These two are the new things which we are studying under MATLAB in today's session. So again, going to the MATLAB model like this. So I have taken from and go to also. I have taken this gain also, and I have taken this scope also, right? Now what I'll do, I'll take this voltage parameter like this, and I'll name it the go-to value as volts. Okay, then the scope is there. Let me take 2 to 3 scopes. Let us see what I'm going to do with this. Okay, let me take the mux also. So mux I have selected. Now here you have a mux. Okay, mux is also done. So this I'm giving over here. See, here I have selected the value as V as voltage for the source input. So the from also we have to take the value as V only. Then it will be matching with the parameter. Okay, the scope is connected to the output like this. Let me take another go to and from. So I'll go with another parameters like this. And again I'll go to the MATLAB. Very quickly I'll connect this to this one, and this ammeter to this one. Fine. I think you understood what I have done here. See, current is measured in ammeters, so that is in amperes. Voltage is measured in voltmeters, that is in volts. Okay, and the combined scope is given like this. Also, individual scope also I'll select. So in this scope, I'll take the file value I'll take the number of inputs as 2 and the output configuration also to see the layout with 2 outputs. So that is also done. So individual C also I can select like this. Okay. And here input voltage is 230 volts and the maximum value of voltage we got as 325. So what I'll do, I'll multiply with SQRT of 2 like this with frequency as 50 and I'll close it. Now input voltage is given, resistor is 2, inductor is 0.2 henries, capacitor value is 100 microfarads, and I'll take the stop time to be 0.06, and now I'll run the model. Let me see what I'm going to get. Okay, so when I look into the output here, yeah, you can see the voltage value, it is 300 above and it is 400 below. So exactly over here, if at all you focus on the lens like this, see 320 and 330, say 325 was the value, so between 330 and 320 the value is 325 approximately. So that is a peak value of voltage we got over here. Okay, and you can see here we have obtained the output in terms of auto ordinary differential equations with 45. Let me change it to the variable parameter with another value. So variable step I'll select with OD 15 and let me check what I'm going to get. Okay, so once again I'm running this. Now you can see the waveform is somewhat better compared to the previous waveform, and when you look into the individual waveforms you can see the voltage is this upper waveform and the current is lower waveform. We got the value of current to be 10.47. We can see here we got the value of current approximately the 10.47 only. So between 10 and 11 it could be 10.5 and it is 10.47, right? So what we are going to do, we'll reframe the waveforms like this. Okay, so these are the value of voltage and current waveforms. Now we will go with the another concept also, that is, see here we have the resistance value, resistor voltage as 20.94, inductive voltage as 657.8 volts and capacitive voltage as 333.26 volts. These three values are very important. Okay, so I can do even that also. What I'll do, I'll take a voltmeter connection. I'll connect the voltmeter like this over here. These two parameters let me keep aside. Okay, another volt parameter I'm connecting like this, and third parameter like this. Okay, now one voltage is across resistor, so that voltage is across resistor. One voltage is across inductor, so that voltage is across inductor, right? One voltage is across capacitor, so that also we are doing with the help of this connection. Okay, these three voltages we can account it for. I'll again take this scope. I'll take these three parameters. So I'll have three inputs because of three voltage parametric variations. And for view also, I have to go with the layout of three parameters like this. So that is also done. Now I'll increase the scope size like this. Now this is the resistor voltage, then the inductor voltage and the capacitor voltage. Okay, and let me run. So if at all you check the outputs, this is very important. See, you might be afraid of this waveform. Don't worry about this. The style configuration you can change it. So here you can see there is a marker O. That's why it is shown as O line. If at all I am selected as none, so it will be like this waveform. So see the voltage across resistor was 20 point something. The voltage across inductor, it is 600 above. So you can see here the value we got here as above 600. So it is above 650 and below 660. Okay, then capacitor voltage, it is 300 plus. So you can see it is above 320 and below 340. So it was 333 approximately. We got the same value. So these are the voltage waveforms what we across the capacitor. I told you I will make sure what is gain also. So if at all I remove this, go to like this, I connect through gain. See what the output we got here. That is important. We got the output here. Seeing that the voltage waveform is higher in magnitude, whereas the current that is 10, it is lower in magnitude, and the waveforms are somewhat mismatched. You cannot say whether what is leading or what is lagging. In fact, current is seems to be almost DC in nature. So I can remove this confusion with the help of some alterations. So I'll take this output voltage and gain parameter, that is 325, right? So what I do, I'll divide it by 10. So it would be 20, 300, 325 would be 32.5 if at all I divide by 10. Okay, then I'll again see the waveform. Now you see how beautiful is the waveform. Actually this we know that this is 32.5 because it got divided, and the current waveform is also shown. Now what is the catch here? That inductive reactance, we got the value here. Remember, we got this XL greater than XC. So that is what has happened over here. XL greater than XC, and that is why current lags the voltage. So that you can easily observe over this waveform. This blue waveform is current waveform and yellow waveform is voltage waveform. So current is lagging the voltage because XL is greater than XC. So that's all for today's class. I hope you like this particular session about MATLAB. So what we have seen here, we have seen the calculations of voltage and current through the elements. So voltage is 325.26 volts, current is 10.47 amperes. Then also we have seen the voltage across R, L and C individually like this. And this is how you can study about the passive elements applied to the AC signal. So I hope you like this video. Please subscribe to this channel and press the bell icon for the future notifications. Stay connected to our channel.